All right, guys, we have spent a lot of time solving equations. Now we're going to move into solving inequalities. So first of all, let's talk about the difference. An equation is a mathematical statement with an equal sign. An inequality is a mathematical statement that does not have an equal sign in it. It has either greater than less than, or greater than or equal, or less than or equal. But the line underneath the sign, that's going to give you the or equal. Okay, so that's the main difference. An equation has an equal sign, an inequality has an inequality sign. Now, what about solving them? Well, great news. You've gotten really good at solving equations, so you're already really good at solving inequalities because you solve them exactly the same way. We're going to use the same exact steps, the same exact rules. We're going to ask ourselves the same exact questions. So really, you already know how to do this. Let's just go through this one. I have 5 times the sum of x and 3 minus 2 is less than or equal to 23. Here we go. Anything I can simplify over here? Right off the bat, I definitely have distributive property. So that's 5x plus 15 minus 2. And then I notice, okay, well, I have like terms. Same variables raised to the same power. These have no variables, so they are like terms. And that is 15 minus 2 is 13. So I have 5x plus 13. I still have less than or equal, and there was nothing to simplify on the right-hand side. So now I'm down to a 2-step inequality, not equation, and I'm going to solve. Work with the numbers on the same side of the equal sign as x, because my goal is to get x by itself. This was a positive 13, so I subtract 13. Again, I just bring my sign down. 23 minus 13 is 10. I need 5 by itself. I need x by itself. So I divide by 5, and x is less than or equal to 2. This is where one of the main difference, or the main difference, between equations and inequalities are. When we solve an equation, we get an answer, one number that we can plug back in that makes the equation true. With an inequality, we get a whole range of numbers, okay? So for example, x can be any number that is less than or equal to 2. So let's pick a number less than 2. How about 0? What if I pick 0? I'm going to take 0 and I'm going to plug back in. 5 times 0 plus 3 minus 2. And I want to know, is that going to be less than or equal to 23? Well, 0 plus 3 is 3. 3 times 5 is 15. 15 minus 2 is 13. 13 is less than or equal to 23. Is that a true statement? It sure is. So 0 works, but 0 is not the only thing that works. Every single number that is less than or equal, so equal meaning including 2, is going to make this statement true, okay? So this was exactly the same as solving equations. In our answer, we get a whole range of numbers versus a single number. Now, there is one special rule. And this is where mistakes are going to be made if you don't pay real close attention. So everybody listen up. If you multiply or divide both sides of the equal sign by a negative number, the inequality sign must be flipped in order for the inequality to end up true. Okay? So let's look at how that works. I have 5 minus 6x is greater than 17. Okay, I first subtract 5 from both sides. That's a positive 5. 5 minus 5 is 0. I'm left with negative 6x is greater than 12. Okay, nothing has changed. All I did was subtract 5 from both sides. That's not multiplying or dividing. That was subtracting. But now I see that I have a negative 6 times x is greater than or equal to 12. I need x by itself. Opposite of multiplication is division. Right here, I see that I am dividing by a negative number. This is where that rule comes into place. I must flip the sign. And let me tell you, if I were you, I would write that sign down before I even simplify the math. So I come down and right away, I flip my sign. It went from a greater than sign to a less than sign. I write that down right away so I don't forget to do it. Then I go back and say, okay, that's canceled. And 12 divided by -6 is -2. So I end up with x is less than -2. Now I can choose any number less than -2. I can plug it back in and I will have a true statement if I got this right. Can I plug -2 in? Let's try it. So 5 minus 6 times -2 should be greater than 17. -6 times -2 is positive 12. So I have 5 plus 12 is greater than 17. 17 is greater than 17. Is that true? No. 17 is not greater than 17. 17 is equal to 17. -2 is not part of my solution. Only the numbers less than -2 will make this statement true. So -2 is not part of my solution. Okay? If you have trouble when you get to the negative numbers, knowing, less than and greater than, make yourself a number line. Let's make one right here. Okay, if I have 0, -1, -2, -3, I can visually see where the numbers are bigger and where the numbers are smaller. Here's -2 right here. We know on a number line, the further left you go, the smaller, right? So what if I would have plugged in -1.99999? Because in my normal math brain with positive numbers, 1.999 is smaller than 2. But over here, is 1.9999 smaller than 2? No, negative 1.99 is here. That's bigger than -2. So do not think that it is too elementary to draw a number line. It is not. Use a number line if you need it. If you start to get kind of jumbled, draw that number line real quick just to straighten your thinking out. Okay? So solving equations and solving inequalities follow the same steps, the same rules. You ask yourself the same questions. The process is exactly identical, with the exception of the one rule that if you multiply or divide both sides of the inequality by a negative number, you must flip the inequality sign. That is the one part of the process that is different. The other main difference is that in your answer, when you're solving an equation, you're going to get an answer, one, unless you get all real numbers or no solutions. In an inequality, you're going to get a range of numbers, like all of the numbers less than or equal to 2. Those are the differences. Let's practice.